Next example in the notes. A water runs into a conical tank at a rate of 9 feet cubed per minute. The tank stands point down. So, cone point down. Water is going into it at a rate of 9 feet cubed per minute. 9 feet cubed per minute is going to be a rate, so it's going to be a something dt. What? What type of measurement is feet cubed? Volumes. This is dV dt. So use units to help you if you're unsure of variables. The tank stands point down and has a height of 10 feet and a base radius of 5 feet. How fast is the water level rising when the height of the water is 6 feet? How fast is it rising? So what we want to solve for is dH dt. Okay, so we want to come up with an equation that relates our variables. What's the equation of a volume of a cone?
1/3 pi r squared h.
Okay. A problem with this equation is that it's talking about radius, and we're not really given any information about radius other than that the whole tank has a radius of 5. We're just dealing with the water, and we don't know anything about the water radius. A beautiful thing about cones is that they have a nice symmetry that happens in them. We get some symmetrical triangles here, studied in geometry. So if the full cone has a ratio of 1 to 2 for radius to height, any level will have that same ratio. So we can set up a secondary equation and say that radius to height is equal to 1 to 2. That's a ratio that can relate radius to height. So our radius is always going to be equal to half of height, no matter how high the water is. And we can plug that into then our starting equation and get rid of a variable. Let's change it to pi thirds. Radius is 1/2 of h. Radius is supposed to be squared times h. Clean that up. When I square a half, it's going to make a 4th, so I'm now up to pi 12ths h cubed, or I guess down to pi 12ths. Can we plug in numbers for v or h? No, because they're both changing. The volume's changing, the height of the water is changing, so we need to take a derivative at this point in terms of time. So dV dt is equal to what? 3 down, so 3 pi over pi over 4 if we reduce. Now we can plug in what we know and hope there's only one thing left, and that the thing left is what we want to know. 9 is equal to pi 4ths times 6 squared dH dt. And dH dt is what we wanted to know.
Isn't height 6 feet?
Yes.
Oh, so why couldn't we plug in the height to the h3?
Because the height is changing. The water's draining, or actually it's filling at a rate of 9 feet cubed per minute. So the height of the water will rise as the volume is changing. So then, let's see. Over here we get 9, and then this is going to be 36 pi over 4 dH dt, or that is the same thing as 9 pi, and I end up with 1 over pi feet per minute is dH dt. So that is how fast the water is rising. 1 over pi feet per minute. I was just going to say hopefully it'll catch up, but no, it appears it stopped working. Sorry. It stopped working and then it decided, oh, nope, oh, nope, back.